Okay, as we take a look at this first problem, directions say list all numbers from the given set B that are members of the given row number subset. Then it gives us the subset of B equals, and so what we need to remember is we need to use the table above that tells us what kind of numbers we're looking at. So looking at your table, so remember your natural numbers are those numbers that come to you naturally. So that set would be 1, 2, 3, 4, 5, and so on. So these are your numbers used for counting. Your whole numbers includes all your natural numbers and 0. It's got 0, 1, 2, 3, 4, 5. Your integers is your next set. So on your integers, that would be the set of all whole numbers and their opposites, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. Your rational numbers is any number that can be expressed as a ratio. In other words, any number that can be a fraction. So any number that can express as a fraction. And then, of course, irrational would be any number that can't be expressed as a fraction. So as I look over this list right here, so I'm going to go ahead and write down this list of numbers that we have on our review. So it says that in my set I have B equals, and then it gives me the set of, it says 14, and then it says we got the square root of 5, and then we got -24, and then it says we got 0, and it says we have 0.6 repeating, and then it says that we have the square root of 16. So there's my set of numbers. So we know the natural numbers are going to be those numbers that are curves to us naturally, so like 1, 2, 3, 4, and 5, and also anything that can be reduced down to that. So as I look at this set right here, 14 is going to be a natural number. The square root of 5 is irrational. So -24, remember that is going to be your integer. So 0 will be a whole number, 0.6 would be your rational, and then also the square root of 16 can also reduce down to 4. So it looks like our answer is going to be 14 and the square root of 16. So those are your natural numbers. On number 2, they give us this equation, or this algebraic expression. It says we've got y minus 6x all over 4x plus xy. It says evaluate the algebraic expression for the given values of the variables. And then it gives us these two values that it wants us to evaluate it for. So x equals -3 and y equals 1. We're just going to use substitution and then simplify the resulting expression. So I'm going to substitute this in. So here's my y is equal to 1, so I substitute that in. This becomes 1. And -6 times -3, so substituting that in. And then we've got 4 times -3, substituting that in. And x is -3, substituting that in. And then y equals 1, substituting that in. Once you've got all those substituted in, we just go ahead and simplify it. So simplifying this, following our order of operations. Here we've got a -6 times -3, so that's going to be a +18. So now I'm left with 1 plus 18. And then in my denominator here, I've got 4 times -3, which gives me -12. -3 times 1 is going to be a -3. So I'm just combining my like terms together, or combining my numbers together. I got 1 plus 18. So 1 plus 18 is going to give me 19. And -12 minus 3 is going to give me -15. So that leaves me with the answer of -19/15. Okay, number 3. Number 3 says that I have this expression here. It says write the algebraic expression without parentheses, or in other words, simplify it. So I have 1/5 times 5x plus -7x plus 7x. So simplifying this, you'll notice that first off, this right here, -7x plus 7x, that's going to give me an answer of 0. I got 1/5 times 5x, so that's just going to be 1x. I add those together and I get x plus 0 is equal to x. On number 4, directions say on number 4, simplify the exponential expression. I'm going to multiply my numbers together, and then I'm going to multiply my variables together. There's my two numbers, -3 times -6. That's going to give me a +18. And I'm going to go ahead and multiply x to the 5th times x to the 6th. So x to the 5th times x to the 6th, remember that means you add the exponents. So that's going to give us x to the 11th. And then we've got y times y squared. So add the exponents together and get y to the 3rd. So your answer is going to be B, which is 18, x to the 11th, y to the 3rd. On number 5, it wants us to write this in scientific notation. So remember, scientific notation is any number between 1 and 10, and is a multiple of 10 to a power. So they give us this as 0.0000038893. So we're going to have to go ahead and move this decimal. So here's my decimal right now. I'm going to move it over 1, 2, 3, 4, 5 places. I'm moving it 5 places to the right. So this becomes 3.893. And then remember, this is a multiple of 10, so I put times 10, moved it how many spaces to the right? So I moved it 5 spaces to the right, so that'd be to the -5. So that answer is going to be C. So 3.893 times 10 to the -5. On number 6, we're going to simplify this radical equation or radical expression here. We've got the square root of 68. So remember, you're searching for the perfect squares that go into 68. So make sure you know your list. You got the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, so on and so forth. So make sure you familiarize yourself with all those perfect squares. Square root of 49 is 7, 64 is 8, square root of 81 is 9. And you want to familiarize yourself with at least the first 15. And so that's why I've written this down. So you'll notice that the perfect square that goes into 64 evenly is 4. So I'm going to break this down. The square root of 4 times the square root of 17. The square root of 4 is equal to 2. And you still have the square root of 17. So that would be your answer. 2 square root of 17. Okay, on this next one, there's 2 ways to do it. So you have the square root of 144 x cubed divided by the square root of 4x. Well, we're going to go ahead and just divide it out. So you can divide this out, or you can actually take the square root of 144, but we'll just go ahead and divide it out. So 144 divided by 4 comes out to be 36. We have x cubed divided by x gives us x squared. Now we can go ahead and simplify this down. So simplifying this down, we'll take the square root of 36. And that's going to give us 6, and the square root of x squared is just x by itself. And then, as a reminder, I went ahead and wrote down your perfect squares for your variables. So remember, the square root of x squared is x. The square root of x cubed is the square root of x squared times the square root of x. And the square root of x squared is x square root of x. The square root of x to the 4th is x squared. The square root of x to the 5th is the square root of x to the 4th times the square root of x. And the square root of x to the 4th becomes x squared. And you still left the square root of x. So on and so forth. The square root of x to the 6th is x to the 3rd. So if they're even, it's a perfect square. You just take half of it, so on and so forth. Okay, number 8. It says add or subtract terms whenever possible. So we've got 2 square root of 3, 8 square root of 75. So as a reminder, remember, addition and subtraction requires like terms. In this case, my terms would have the radicals. So you'll notice that right now, these 2 radicals are not alike. This is square root of 75, this is square root of 3. So I'm going to go ahead and simplify this down and see if I do end up with like radicals. So the square root of 75, I can break down to the square root of 25 times the square root of 3. So breaking this down further, so notice the 2 square root of 3 doesn't break down. So now the square root of 25 is 5, so I'm left with 8 times 5 times the square root of 3. So 8 times 5 is going to give me that 40 square root of 3. Now that I've done that, you're going to notice that I do have like radicals. So once your radicals are alike, square root of 3 and square root of 3, that means you can add it together. So 2 square root of 3 plus 40 square root of 3 is going to be 42 square root of 3. So that answer is B. On number 9, it says we've got 5 all over 9 minus square root of 2. So it's to rationalize your denominator. So we're going to multiply the denominator by the conjugate. So we're going to multiply both top and bottom by, both numerator and denominator by 9 plus the square root of 2. So now that I'm multiplying by 9 plus the square root of 2, I'm going to go and distribute that 5 on through. So I got 5 times 9 and 5 times the square root of 2. And when I do that, that's going to give me 45. So 5 times by 9 is 45. 5 times the square root of 2 is going to be 5 square root of 2. Okay, and I'm going to go ahead and multiply 9 minus the square root of 2, 9 plus the square root of 2. Remember to do FOIL, first outside, inside, last. You don't have to worry about the outsides, insides because they're going to cancel out. So all you really have to do is do the firsts. So 9 times 9 is 81. Then we've got to subtract. And square root of 2 times square root of 2 is 2. So then take 81 minus 2, and you get a total of 79. So your answer is 45 plus 5 square root of 2 all over 79. So that answer is B. Okay, on this next problem, on number 10, it says that it wants us to go ahead and perform the indicated operation, writing resulting polynomial in standard form. So it looks like they want us to add these two polynomials together. So we've got 4x to the fourth minus 7x cubed plus 9x squared plus 5. We've got 3x to the fourth minus 2x cubed plus 4x squared plus 1. So to be able to add these together, you're going to combine like terms. Like terms mean they have the same variable, same exponent. You're going to notice your answer will always end up with the same variable, same exponent. So let's go ahead and find our like terms on this problem right here. So our like terms, I notice in my first term, 4x to the fourth, 3x to the fourth, those are like. So I add those together, I get 7x to the fourth. I've got negative 7x cubed, negative 2x cubed, those are alike. Add those together, negative 7 plus negative 2 is going to be a negative 9x cubed. I've got 9x squared plus 4x squared, those are like. So I add those together, I get 13x squared. I've got 5 and 1 like terms, so I get the answer of 6. So those are my like terms combined together. So my answer is going to be 7x to the fourth minus 9x cubed plus 13x squared plus 6. That answer is D. This next problem, number 11, says it wants us to find the product. So remember your rule for multiplying these problems together. So it says to go ahead and find the product or multiply these two polynomials together. So remember the rule says multiply all the terms of the one polynomial by all the terms of the other polynomial. So that's our rule for multiplication. So that means I'm going to take this x, I'm going to multiply by x squared. So that's going to give me x cubed. I'm going to take this x times 3x, that's going to give me 3x squared. I'm going to take this x times 9, that's going to give me plus 9x. Now that I've done that, so you're going to notice I'm going to take this negative 3 and multiply it on through, so it's negative 3x squared minus 9x minus 27. So you multiply all the terms of one polynomial by all the terms of the other. So I separated it out right here so everybody can see that separate. Now I'm just going to combine my like terms, simplifying down what I can simplify down. So I'm noticing anything that's alike. So finishing off this problem, I've got x cubed. Doesn't combine with anything. So I've got 3x squared, negative 3x squared. Those are going to cancel. I've got 9x. I've got negative 9x. Those are also going to cancel out. And then I'm still just left with my minus 27. So my answer is going to be x cubed minus 27. On number 12, I've got two binomials being multiplied together. I've got x minus 11 times x minus 10. I'm going to use FOIL. So just as a reminder of what FOIL stands for. FOIL stands for first, outside, inside, and last. So that's what I break it down as, so that everybody can see my first, outside, inside, and last. So let me scroll on down here. So notice when I have those two equations there, x minus 11 times x minus 10. So I'll just rewrite it here so I don't have to scroll up to it. So I've got x minus 11 times x minus 10. And I'll make this x look a little bit better real quick here. So notice here's my firsts, which would be these two right here. That's x times x, which is going to give me x squared. My outsides is going to be these two right here. So I got x, and I've got a negative 10. So that's negative 10 times x, that's negative 10x. My insides are going to be these two numbers right here, so negative 11 and x, so negative 11x. My insides is negative 11x. And then my lasts is going to be this negative 11 and this negative 10. I multiply those together and I get positive 110. So now that I've done that, I'm just going to go ahead and combine my outsides and insides together. So my outsides insides got negative 10x minus 11x gives me negative 21x. And there's my answer of x squared minus 21x plus 110. On number 13, I want us to take x minus 14 squared. When I do this problem, the easiest way to do it is just to write it down twice and then FOIL it. So first outside, inside, last. So notice this being squared means you have two of them. So that's x minus 14 times x minus 14. So I'm going to go ahead and FOIL those two out. So FOILing those. So here's my first. Got x times x. That's going to give me x squared. My outside is going to be x and negative 14. So that's negative 14x. Here's my two insides. It gives me also negative 14x. And then my two lasts are going to be right here, negative 14, negative 14. Multiply those together and get 196. So now combining like terms, I've got a negative 14x, negative 14x. My outsides and insides combined together. That gives me x squared minus 28x plus 196. Number 14 gives me this polynomial. It says factor by grouping. So x cubed plus 2x squared minus 3x minus 6. You've got a 4-term polynomial. We're going to go ahead and put parentheses around the first two and the last two. We'll group them together like this. So you notice I've rewritten that down. Here's x cubed plus 2x squared minus 3x minus 6. Now that I've put parentheses around them, now I'm going to go ahead and factor each set of parentheses separately. So out of this x cubed plus 2x squared, I'm going to factor on x squared. And when I do that, x cubed divided by x squared gives me x. When I take this 2x squared divided by x squared, I get plus 2. So I factored x squared out of the first set of parentheses. I'm going to go and factor out the second set of parentheses in negative 3. So I take negative 3x divided by negative 3, I get x. And then negative 6 divided by negative 3 is going to be plus 2. Now that I've factored out most, one of them is a variable, the other is a number, I'm going to go ahead and factor out the equation. I have a common equation on both sides. I got a common equation of x plus 2. So now I'm going to go ahead and factor out that common equation. So when I factor out the common equation, my x plus 2 comes out front. Now this divided by x plus 2 gives me x squared. And negative 3 times x plus 2 divided by x plus 2 is going to be minus 3. And that will be your answer. You have x plus 2 times x squared minus 3, so that answer is going to be C. On this next problem, number 15, we've got 25x squared minus 49. So you're going to notice that on this problem right here, the directions down number 15, factor the difference of two squares. So notice your outsides, insides are missing. So that is an indicator that you're looking at a product of conjugates. So notice the first term and the last term are both perfect squares. The outsides, insides are missing. So to factor this, you just take the square root of the first term. So the square root of 25x squared is 5x. Square root of the last term, positive 7, negative 7. And that combination, which is your conjugate combination, gets rid of the outsides, insides. And you can refollow that to check that and see that that's what's happening there. So number 16, the directions on number 16 says, simplify the rational expression, find all numbers that must be excluded from the domain of the simplified rational expression. So your directions for simplifying rational expression, you're going to factor the numerator and the denominator. and then cross out anything that looks like. So notice this 18, my factors of 18 that add up to 11 is 9 and 2. So that's going to factor to x plus 9 times x plus 2. The factors of 54 that add up to be 15 is going to be 9 and 6, because 9 times 6 is 54 and adds up to be 15. So that factors to x plus 9 times x plus 6. Now that I'm done factoring it, I can cross out anything that looks exactly like. My x plus 9s look exactly like. So my answer is going to be x plus 2 times x plus 6. I'm going to exclude those numbers that make my domain 0. So you'll notice that this x plus 9 right here, if the value of that is negative 9, that'll give me a 0 here. And x plus 6, if that value of that is negative 6, that also gives me a 0 there. So I can't have zeros in my denominator, so that's why I exclude that domain of negative 9 and negative 6. So your answer ends up being x plus 2 over x plus 6. And then remember, x cannot equal negative 9 or negative 6. And that answer looks like it matches with A. On number 17, it says we have 3 all over x squared minus 3x plus 2 plus 5 all over x squared minus 1. The directions say add or subtract is indicated. So we've got to find our common denominator. So to do that, we're going to factor the denominator to find the common denominator. So notice I'm going to factor this right here. X squared minus 3x plus 2 factors to x minus 2 times x minus 1. Because negative 2 times negative with a positive 2, they add up to be our negative 3. I'm going to factor this other one. This becomes x plus 1 times x minus 1. So x squared minus 1 is a perfect square binomial combination. Fraction of the conjugates of x plus 1, x minus 1. Okay, now that I've done that, I'm going to go ahead and get my common denominator. So notice my common denominator is going to be the x minus 2, the x minus 1, and the x plus 1. So you'll notice this x minus 1 is already included in this other one, so I don't have to worry about it. So here's my 3 binomials. That is my common denominator. It's x minus 2 times x minus 1 times x plus 1. So I put both of my numbers over that, and I multiply by the missing denominator. So notice this one right here. I had a 3 right here. This is a 3. So the missing denominator that I had in common was this x plus 1. So I got to multiply both numerator and denominator by it. So this right here was a 5. And the missing denominator on this one was x minus 2. So notice the x minus 2 is what is missing. So I multiply both numerator and denominator by it. The same thing here. Notice that that x plus 1 is what was missing. So I had to bring it in. So I multiply both numerator and denominator by it. Okay, now that I've done that, I'm going to go ahead and distribute my 3 on through. So distributing this 3 on through, I get 3x plus 3. Distributing the 5 on through, I got 5x minus 10. Now that I've done that, I just follow my laws of fractions. My laws of fractions say I'm going to go ahead and combine my like terms. So add the numerator and keep the same denominator. So adding my numerator together now and keeping the same denominator, I have 3x and 5x is going to give me 8x. I got 3 and negative 10 is going to be negative 7. And my common denominator is right here, so I just keep the same denominator, which is x minus 2 times x minus 1 times x plus 1. And that'll be your answer, 8x minus 7 over x minus 2, x minus 1, and x plus 1. Okay, number 18, it says that I have 1 over x plus 1, and that's all of 1 over x minus 1. So notice I got a complex fraction. Definition of complex fractions, you've got a fraction inside the fraction. So here's my fraction inside my fraction. So here's my fraction, my numerator. Here's my fraction, my denominator. So my rule says I'm going to multiply all terms by the least common denominator. I just need to locate where my denominator is at. So this denominator is x. This denominator is 1. This denominator is x. And this denominator is 1. So that means that my common denominator is going to be that x. So to simplify this down, I'm going to multiply all of my terms by x. So when I do that, I multiply this first one by x. So x all over x. And that's going to simplify down to 1. So this simplifies all the way down to 1. When I multiply this next term by it, nothing simplifies down, so I'm just left with my x. When I multiply this term by it, x over x, again, those are going to cross out. That's going to be 1. When I multiply this term by it, that's going to be minus x. So my answer is going to be 1 plus x all over 1 minus x. And that answer matches with B.